Hello, my name is Earl, and welcome to today's video. And we are going to be talking about the microprocessor, which consists of ROM, which is read-only memory, and processor that computes calculations, then stores the result onto a RAM, which is the random access memory. And we're gonna be doing a simple subtraction of 8 minus 3 and storing the value into the random access memory. And we're going to be putting the binary number for 8, which is 1000, then putting the binary number for 3, which is 0011. And we're gonna want to store this 3 onto store B, so we could use it for the calculations. And we're going to select the address this Roam 1 is connected to, which is address 1. Then we're going to turn on the enabler for where we want to store this digit and turn on read mode, then run the clock cycle. Then we have successfully stored this number from ROM onto store B. We're going to turn off the enabler since already have the digit we want to store. Then we're going to switch over to the address um, on which ROM0, our next number, is stored. All right, we're gonna its address 0, which is connected to ROM1. We're gonna take 8 and run it through the alumini. All right, I guess that was kind of mess. All right, we're gonna turn on this enabler, which should get the result for 8 minus 3. And yeah, let's run it. And we should turn this on, and uh, run the clock cycle again. And you have the value for 8 minus 3, which is 5. And we're gonna want to store this value from the accumulator. And now we're gonna turn on this off, we're gonna turn this off, and we are going to select we're gonna be storing this value on RAM 6 for this video. And now we're gonna select address 6. And how you put that in binary, 110 is the binary number for 6, which is 1110. Correct. So we want to turn this buff, and we're gonna want to move this from the accumulator to the RAM. And what the buffer does, it buffs the number before it stores it, right? And watch as I turn on the buffer, we're gonna get an error because like we're still on read mode. And now we have to turn off the read mode and turn on write mode. And now we're gonna turn this buffer on since we already have the address for RAM 6, and we're gonna run the clock cycle again. And we have successfully stored the result from our calculation and stored it onto a RAM. And now we have a couple of questions we have to answer. Is this machine digital or analog? Personally, I think it's digital because like most of the calculations computations are done in binary, which yeah, just basically means it's digital. What is a bit? A bit is a single unit, that single cell that stores a binary character. Yeah, and each microprocessor registers holds up to 4 bits of binary digits. What is a register? A register is a small, fast, accessible memory. Which, yeah. Why are they important for computers? They hold data and instructions. making them available for quick access. And where can we find these registers in the microprocessor? We have store B, the accumulator, and each of the three RAMs, which totals up to five registers. And we that's the end of the video, and thank you so much for watching.